Hello everyone, so in this particular video we are going to continue our Mediapipe series, and in this video we are going to do interactive image segmentation. So basically what is this? This is like the image segmentation process. However, in this case you can predefine or you can custom define your own for example object. Okay, so let's say that you are having this particular image, okay, and you want to just take out this particular chair. So what you need to do in this particular image, you can go and just specify the coordinate of this or any place in this chair. Okay, it need not be in the center, it can be here also, it can be here also, whatever. You just specify that and the model will try to figure out what is the outline of this. Now then you can what you can do is you can basically extract it from the image, or you can blur the background and so on and so forth. You can do a couple of things over here. Okay, so you can say you can divide an image into two regions: a selected object and everywhere else. So whatever is selected, for example, if you select this pot, then this entire pot will be your at least this particular vase is going to be your foreground or the selected object, and the rest of it will be background. Okay, so it will basically take out the image where you point to, and I'll show you in the code where how you exactly point to. You can use this task to interactively select an object in an image, correct, as I have said, and use the output to apply effects on the image, such as color overlays and highlighting and other stuff. That all that stuff is basic. We understood the main thing. Okay, so obviously I took this code example over here, and what I did is I tried to change this example in such a way that it is reduced to the most basic form, so that we can have a clear understanding of this. Again, nothing too great over here, same thing as segmentation, category mask that we will use, confidence which we generally don't use. Okay, again, if you want to try out different confidence scores, you can do that, but we generally prefer the default values, because obviously those default values have been there because they have been tried and tested to perform the best. Okay, so like this only, default values are just not taken randomly. They are the best possible general settings that are given by the company itself. Okay, so in this particular the model that we are going to use is just one model is there, which is a Magic Touch model, and it is also the recommended one. Basically it says that model uses a convolutional neural network similar to mobile net v3 architecture with a customized decoder. Okay, fine. So the model is over here, you can go and download it. If you click over here, it will download. I'm not going to do that. Okay, so let's start with the coding part. Basic, again, this notebook will be there in the description. You can go and take it. It will be uploaded in GitHub. Okay, so what you do is you will take Mediapipe from here, and after that you're going to paste this one, which is the magic touch dot tf lite. So you're going to hit shift and enter. It will download your model. In my case, I have already done this, so you can see the doggo.jpg that I always show. Doggo.jpg is already here, you can see. Okay, so this particular image, very famous on our channel. So dog.jpg, I did not name it doggo. Okay, so we will again import cv2 and then Google Patch as always for displaying the cv2 images. Okay, again the basic imports NumPy and Mediapipe is always there. Again we are using Python, and we are doing a vision task, and here we also need something called as containers. Okay, now in here there are two things that you need to have. There is this region of interest which we need in this particular case, and also some key point normalizer. We will see what that are, what those are. Okay, so I'll hit shift and enter. Base option, again you'll pass the the path of the model over here, and you want the output category mask. That is the thing that we are interested in, so we'll keep it as true. And base option is something that has already been described over here, so we'll hit shift and enter. Okay, now x and y is basically your in this particular image, how will the model know whether you are interested in this particular chair? So you have to give a normalized xy coordinate. So let me give you an example. Okay, so let's say our doggo.image is something like this. Okay, it's wider and little shorter. So this is 700 pixel. Okay, this is 700 pixel, and this is some 550 pixel. Okay, again rough figures, I'm not sure. This is 756 or 526, whatever. Okay, so this is the particular image. Let's say I want to go here exactly in the middle. What will be the coordinate? coordinate will be x will be 350 and this one will be what, 225, right? The way we represent this one is 0.5 comma 0.5. Why? It is exactly at the half, which means if I go over here, this position is 1/4 of this. It's going to be what is the coordinate? Can you guess? It is going to be 700 divided by 4. But y, again, it is at the center only with respect to y, which is 0.5. Okay, 0.5. Okay, over here. So I hope you understood. What will be this? 350 divided by 350 divided by 2 will be so this will be 1, this will be 2, this is 7, this is 175. So this will be okay, sorry, not my bad. So this will be divided by 700. Okay, so this is going to be 700, 0.25. Okay, whatever, you get the idea, right? This will be 0.25 comma 0.5. I hope you get my idea, right? You have to basically keep the ratios looking from here, okay? So if you give 0.1 and 0.1, it will reach somewhere over here, 0.1, 0.1. Okay, so from here you need to see the x ratio, and from here this. So what is this point? This is 1 comma 1. Okay, now I hope you are able to understand. Okay, so this is just 0.6 comma 0.2. So if you go and look at docker.jpg, if you look at this image, it's so we have to go 0.6 in the x-axis. So if this is the top corner, this is half somewhere over here, 0.6, and then there is 0.6 was there, and 0.2 was there. So 0.2 will be somewhere over here, whatever. Okay, so we'll see what it is. Okay, but I have explained you how to interpret this particular situation. Okay, so now what do we do is we need a simple we have to pass in the image. So we are passing in the image. So the doc.jpg, that is already there. Region of interest we have already seen. So region of interest will be giving you the key points and normalized key point basically. Okay, so a normalized key point, I have explained you what that means over here. Okay, this was all normalized key point. After that, what you do, you pass in through the segmenter. Okay, and then you get the category mask over here. We will hit shift and enter over here. Here this is only for drawing the particular image. Okay, so excuse me. So after that, what you do, you create image data, which is basically the same as image, and then you have a numpy.zeros. Numpy.zeros is basically going to create a solid image that is all black. After that, you want something called as a mask color. So basically mask is something that is our region of interest, and background is something that is not region of interest. Okay, so background image will be again numpy.0, but again background color will be different over here. Okay, so I'm going to hit shift and enter. Now how will we know what is background and what is foreground? That we will know from category mask not numpy view. Okay, if you remember in the segmentation video, numpy view is basically going to give you the position, this entire what to say function over here, entire this function over here is going to give you the particular positions of background and foreground. What we are doing over here, we are just doing it in the 3 axis, because that is required as a condition in np.where. Okay, and wherever this condition is true, foreground mask, foreground image is what, mask color is what, total white. So our image will be total white, and background is little bit darker gray color. Okay, so I'm going to hit shift and enter, and then over here so here, and let then hit over here. Okay, so in our case this was a completely useless region, so we will change that. Okay, we are going to change it to something. Let me go and show you the docker.jpg. Okay, let me go and see. Let's say we are interested in this pillar. Okay, because I'll have to calculate the exact normalize. You can do that using paint. You can point over here, then you can figure out what is this particular pixel, and then divided by the total length and width. I have explained that one to you. Okay, but I'm right now interested. I'll just keep it at 0.1 comma 0.1 or 0.01 or comma 0.01. Okay, which means we are looking at that particular 0.01 here, also 0.01. Okay, again we'll run everything over here, and we will wait for the final. So you can see over here the railing, or rather the pillar has been taken. Okay, not the railing, I'm sorry. You can see the pillar. Okay, this is the pillar. Now this is not perfect, obviously. It has taken some areas from here, it has taken some, but I have tried with this, it works to a certain degree. Okay, so let's try some other values over here. Instead of 0.01, let's say 0.4 and 0.5. Okay, let's see what we get. See, we can get the dog. Almost there are some so what you can do is you can change over here the percentage sign in place of 0.1, 0.2 also can be there, but it will maybe corrupt the image, but depends. Okay, so you can basically play with these numbers over here, and this is how you do it. Now obviously if you want to implement it, you would want it to have a front end, but I have just shown you how to get this particular. If you want a full-on project on this, you can definitely comment in the comment section, but I think this much is enough for today, because mostly we don't use it, we use segmentation. Okay, but I can definitely think of some use cases where we can be using this particular stuff. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much, and bye.